Okay, we're going to be looking at problem number 3 of practice test 3. A CD rotating about a fixed axis with constant angular acceleration of 2.0 radians per second squared turns through 24 revolutions during a 0.20 second time interval. What is the angular velocity at the end of this time interval? And it gives you a hint. The initial angular velocity is not zero. This, of course, is a problem in angular kinematics, and we do not know the initial angular velocity. We do not know the final angular velocity. We do, however, know the acceleration and the time and the number of revolutions it turned in that time. So we're looking for a way to solve the initial angular velocity. And if you'll recall, we can start with the equation that the change in the angle is equal to the initial angular velocity times the time plus 1/2 times the angular acceleration times time squared. Can we obtain omega I, or the initial angular acceleration? Take a few minutes, pause the video, and solve for the initial angular acceleration. Given delta theta in terms of revolution, we need to now cast it in terms of radians. And delta theta in terms of radians is just simply 2 pi times the number of revolutions, and is 150.8 radians. Now, what do we know? Of course, we know alpha, the angular acceleration, 2.0 radians per second squared, and we know the time, 0.2 seconds. And solving for the initial angular acceleration, we set that equal to the numbers, and we come out with the initial angular acceleration equal to 753.8 radians per second. Now what else? Well, we need to find the final angular velocity. So how do we find the final angular velocity? Well, we have that the final angular velocity is equal to the initial angular velocity plus the acceleration times the t, and that gives us 753.8 plus 2.0 times 0.2 seconds, and we have 754.2 radians per second. End of module.